Hello, we are Group 1, Section 1 from Building Science and Sustainability. Today we would like to present our project for measurement and assessment of selected IAQ parameter in Traffic Engineering Technology Laboratory. Before we go further, I would like to introduce my teammate. This is our team. First, my name is Muhammad Nur Iman bin Ishaq, CN210403. Next, Nur Izzati binti Rakawi, CN210374. After that, Nik Kaula binti Aznan, Nik Aznan, CN210381. Lastly, we have Shazatun Nazira binti Saroji, CN210255.
Introduction of our project is research on the urban population has confirmed that people spend more than 19% of their daily lifespan in indoor environments, increasing concerns about the importance of indoor air quality AAQ on human health. This is particularly critical in university or school. Consider that young people spend more than 60% of their time in university, and they are very sensitive to indoor populations, also including a significant decrease in efficiency of student learning process and cognitive performance. According to the EPA definition of IAQ is the air quality within and around buildings is structure, especially as related to the healthy and conform of building occupants.
Literature review: Indoor air quality. In Malaysia, office buildings are required to provide a healthy indoor atmosphere with good indoor air quality (IAQ) to protect staff members' physical and mental well-being while they perform their jobs there. This is because their health will have an impact on both how well they perform at work and how well the business performs. The majority of countries in the world today recognize indoor air pollution as a serious economic, environmental, and health issues. Researchers have discovered that indoor air contaminants occur more frequently and at greater levels than those found in outdoor air.
Literature review for Sick Building Syndrome, or SBS. Sick Building Syndrome is a major problem in Malaysia, where indoor air quality is often compromised due to a variety of factors, including inadequate ventilation, humidity, and the use of toxic building material. One of the main causes of FPS in Malaysia is indoor air pollution, which can be caused by a variety of factors, such as smoke, chemicals, and VOC, and poor ventilation. In a study conducted by R. Abdullah and R. Fadilah, they found that air pollutants such as formaldehyde and benzene and toluene were present in indoor air environment in Malaysia homes, and this could lead to respiratory problems, eye irritation, headache, and other symptoms associated with SBS. Literature review for building-related illness, or BRI. Building-related illness is a significant concern in Malaysia due to the country's humid climate and poorly ventilated building. A study conducted by Azila et al. 219 reported that 58% of office workers in Kuala Lumpur experienced at least one symptom of BRI. The most common symptoms reported were eyes, nose, and throat irritation, headache, and fatigue. Poor indoor air quality, inadequate ventilation, and indoor pollutants such as fungi, dust, mite, and volatile organic compounds were identified as the major cause of BRI.
This information of the laboratory that we select in our project. The Laboratory of Traffic Engineering is a center of research and innovation excellence in traffic engineering with global recognitions. Administratively, it belongs to the Department of Technology Engineering. Since its development, the Traffic Laboratory contributes to transportation science through the numerous of academic, scientific, and research activity. The Traffic Laboratory located at second floor, Block G. The laboratory has two exit doors with a two-way door at the front and at the back. It also has 6 windows from the left side of the roof and 1 window from the corridor side.
Parameter for indoor air quality measurement. For temperature, a fundamental aspect of indoor environmental monitoring to ensure the comfort, productivity, and health of building occupants, it involves monitoring and managing the temperature levels within the building. For relative humidity, the process of monitoring and controlling the humidity levels within a building to ensure occupant comfort, health, and the prevention of moisture-related issues. Relative humidity is the measure of the amount of moisture present in the air compared to the maximum amount the air could hold at a given temperature. For air movement, the process of quantifying and assessing the flow and circulation of air within a building, monitoring air movement is crucial for maintaining proper ventilation, thermal comfort, and overall indoor air quality. Carbon monoxide. It involves monitoring and assessing the concentration of carbon monoxide gas in the indoor air. Carbon monoxide is a colorless and odorless gas that can be harmful to human health when present in elevated levels. Lastly, carbon dioxide. It involves monitoring and assessing the concentration of carbon dioxide gas in the indoor air. Carbon dioxide is a naturally occurring gas that is produced through human respiration, combustion processes, and other sources.
Equipment for indoor air quality measurement. AAQ meter is used to measure carbon monoxide and carbon dioxide in the laboratory. It is for regulating the air quality in the living room, workplace, school, and other similar areas. Air quality meters that at least identify the carbon monoxide concentration as well as the temperature and humidity of the indoor air are advised. Equipment for relative humidity measurement. The anemometer displays the lowest, maximum, and average value for each measurement. On the LCD, this measured data can be shown visually. Up to 250 readings for the anemometer, each with the time and date stamp, can be stored. It can quickly and simply calculate the wind speed, temperature, wind chill, dew point, relative humidity, and the air heat index, barometric pressure, and high pressure air versus and end by using the straightforward anemometer like this one. Equipment hot wire thermal anemometer for temperature and air movement measurement. Thermal anemometers, also known as hot wire flow sensor, gauge the flow rate by utilizing one or more low-tech temperature sensors to track the amount of heat loss from the surface. They are often used in the automobile sector to keep an eye on the engine's air intake. This hot wire anemometer is the thermal transducer which has been widely used to measure instantaneous flow velocity. Instantaneous flow velocity may be determined from measurements of electric voltage thanks to the hot wire anemometer.
This is the flowchart for hot wire thermal anemometer for temperature and air movement measurement. This is the flowchart for anemometer for relative humidity measurement. This is the flowchart of indoor air quality meter for carbon monoxide and carbon dioxide measurement.
These are the sketch drawing for the laboratory, and these are the AutoCAD drawing for the laboratory.
Standard that we use in our project is there is more common side effect of indoor air pollution, light and unpleasant odor, but many other go undetected because germs and pathogens do not show symptoms immediately, which later cause greater harm to health. Our assessment and our recommendation of the indoor air and next course of action is based on Industry Code of Practice on Indoor Air Quality 2010. Parameter for air temperature that accessible range is 23 until 26 degrees. For relative humidity, 40 until 70%. For air movement, 0.50 until 0.50 minutes per second. For carbon monoxide, 10 ppm. For carbon dioxide, 1000 ppm.
This is the discussion for result in temperature and air movement. The range of the temperature in the lab is 21.8 degrees Celsius to 24.2 degrees Celsius. 23 degrees Celsius to 26 degrees Celsius is the suitable indoor air temperature range for Malaysia. The temperature is slightly lower than the recommended temperature, but this is problem can be easily solved by adjusting the air conditioning temperature in this lab. This lab air movement can get as high 0.49 ACH and as low 0.01 ACH. The air movement reading in this lab is so low because this lab is in closed space state. This is to prevent the cold air from the room from escaping. By preventing the cold air from escaping, the lab can maintain its temperature. Discussion for result in relative humidity. In this lab, the relative humidity varies between 69.2% and 59.2%. Relative humidity between 40% and 60% is ideal for comfort, as it helps to prevent dryness or excessive moisture in the air. In this room, the relative humidity falls slightly outside of this typical range. Air may feel more humid and clammier, which might lead to discomfort. High humidity can make it harder for sweat to evaporate from the skin, making individuals feel hotter. It can also contribute to mold growth, potentially causing health issues for those sensitive to it. Discussion for result in carbon monoxide and carbon dioxide. In this lab, the carbon monoxide reading is 0.1 part per million or ppm in every section. Permissible exposure limit or PEL for carbon monoxide is 50 ppm for an 8-hour time weight average. Based on this standard, the carbon monoxide level in this lab is significantly below the permissible limit. This indicates that the room is relatively safe in terms of carbon monoxide exposure. The carbon dioxide reading varies between 392 ppm to 430 ppm in this lab. It is advised to stay under 800 ppm and near 400 ppm. This suggests that the room exposure to carbon dioxide is generally safe.
In conclusion, indoor air quality AAQ is a significant factor in maintaining good health. Understanding the harmful effect induced by indoor air pollution will help us to take all the appropriate preventive measures to reduce the possible health risks. As the more pollutant from the outside start to contaminate the air inside the building, indoor air quality has recently grown to be a major health problem on the worldwide scale. Owners or manager of the building need to be aware of how little poor indoor air quality may affect building inhabitant daily life. The spread of infection, illness, as well as the serious health issue may result from a single or repeated exposure to airborne pollutant. Only when the interior air quality evaluation are done may pollutant be found.